Sequence diagrams are another UML diagram that are for tracking the interactions between objects inside of your system. So a class diagram shows you the quote unquote static structure. There's no code running. The class diagram is what it is. It's the relationships you might see. You can think of it this way: when everybody's in bed, they still are friends or parents or relatives or enemies or whatever they are. They're just not doing anything about it right now. Well, the sequence diagram shows everybody awake and in some specific interaction. So a sequence diagram is kind of like a timed sequence of events. So in this case, we can see we start with some objects that participate in the sequence. And the objects are basically in a line across the top, a series of boxes that have these little dotted lines that come across. They're called a tail. And the calls are method calls, operation calls between the objects that are shown as a progression of time, starting at the top and heading towards the bottom. So this case, add happens first, drop happens second, lock happens third. Um, the structure of this then is showing you very visually exactly the sequence of events. You can kind of think of it as a type of flow chart. So registrar calls course roster, then registrar calls course roster again with drop. So it starts with add, then it goes to drop, and then it calls lock, for example. So the important thing here to understand is these are objects at the top, not classes. So for this example, you can see I have a class player and a class ball, and the player might throw a ball, and that might make sense at the top level, but that's not correct because it's very possible we can have multiple players and multiple balls in the game. So I apologize for the sports analogy, but this is a Quidditch example, so it's kind of blending sports and fantasy. So anyway, so in this case, we have a chaser and a quaffle and a beater and a bludger. So we have two players and two different types of balls out there. And so when the beater starts first by batting the bludger, and then the bludger strikes the player, and then the player throws the quaffle. So this sequence can show in. And that's the power of using objects up top, because it's not just simply showing a single static interaction between two classes, but it's showing how different objects that might be created by the system will be interacting. I mean, in a sports sense, there's many, many players, and in Quidditch, there's many, many balls. In a real world, I can have two bank accounts involved in a transfer. I have the transfer comes from and the one it goes to. So I need sequence diagrams to be objects to be able to show me the participants in the interaction, not just simply the static structure that interacts. Now, the other important thing about sequence diagrams is they do show structure still, not necessarily logic. So in this example, my registrar starts by adding a student to the roster. The student then is notified and then makes a payment, but that payment may or may not be successful. It doesn't matter if the payment is successful or not, in fact, because that logic is not what I'm trying to show here. I just want to show the high level structure of what potentially is called. I don't have to show if the payment's successful, return the receipt, else return a fail rejection. That's not necessarily what I'm trying to gain here. I just want to show this standard flow. I might actually instead show two different sequence diagrams, one where payments are successful, one where payments fail, particularly if it's a very complicated flow that comes afterwards. So the other thing I want to point out here is the dotted line right here shows an interaction between two objects, but instead of a call, a method call between two, it shows actually the return value, the return object that's coming back. So in this case, the student object that gets called might be something that the course roster keeps track of, or it might simply be notifying the student based off the parameter that got passed in. This doesn't even necessarily show me the static structure of the class diagram. It shows me again the dynamic calls that are happening in this sequence. So let's immediately take this to code. I'm going to use an example from Java here because it's pretty standard language, but in our code, we typically start a sequence diagram with one specific call. In this case, we're saying the registrar has a call to set up course. So the registrar object comes from the registrar class. And again, if we don't have the name, we'll just kind of assume the capital letter class becomes it. And then we say set up course. Well, this is the first method that comes in essentially from nowhere. You can show an actor out here, or you can just have it come from nowhere. We don't necessarily have to be called by anybody specifically, because code could be called by people or batch processes or web services or anything. So when I have set up course here, you can have parameters coming in. Notice here, there could be something complicated, like a list of students and looping through that, but that doesn't show up here in the course roster. Um, so the course basically is saying like, okay, well, this is the static behavior. I get some stuff, and to the roster, I'm adding a student. I might be doing that one time or 100 times. I can show this, and there's actually a way to show that this it's called in multiplicity, or I can just show it one time. And then you can see the next thing I do in my course is I lock the course. And then notice I can actually call methods on myself. So I can have from my own line a call to another method myself. So the setup course method calls the add to schedule method. So I add the course to the schedule. And this is a private method. Not anybody else can call it, but I might want to show it here to be able to represent the fact that this is how I add courses to the schedule. I start with setting up the course, and that's how I get it added to the schedule. The other thing to point out here is just to remember the complexity of the code doesn't necessarily need to show up in the complexity of the diagram. This diagram, the point of it might be to show the interaction between the roster and the registrar. And yes, it's going to be more complicated and rich than what it is, but again, that code can be internal. The picture is there to tell a story, not a complete story. If I have to tell the complete story every single time, well, I might as well just read the code. And so you get to choose the focus of your sequence diagram. So in general, sequence diagrams are there to show interactivity. You're going to use them to document these complex interactions between objects, particularly when you have a bunch of objects of the same class that are going at the same time. The reality is not every single bit of code you write will have sequence diagrams. I actually use them very rarely, but when I use them, it's really helpful for people to understand a complex interaction or the way the code behaves or the structure of the code. And because it really shows the interdependency between classes. It shows how they can work together or why they have relationships or why two classes that don't keep track of each other might interact so much. And so it's a really useful tool for showing your code in action.